All right, so welcome back, everybody, from the break. Hope you had a chance to stretch your legs and get something to eat. We are going to now kick off our next session, which is network security and cyber attacks users don't see. And to guide us through this discussion, we'll have Robert H. Mayer, Senior Vice President of Cybersecurity for the U.S. Telecom Association, to take us where we need to go. And he's doing a great job of managing things so far, given that his power has gone out and he's working on a 2x4 screen. So we'll make that work. And with that, Robert, I will hand it over to you to take us where we need to go.
Okay, very good. Thank you, Dustin, and welcome to all the participants on this webinar. I think you'll find it informative and hopefully exciting and interesting as well. I'd like to begin by telling you who we have today on the panel, and then we're actually going to go to a video. We're fortunate to have a very esteemed group of individuals in the cyberspace. We have Michael Benjamin, who is the Senior Director of Threat Research for CenturyLink Communications. Dr. James Galvin, who is the Director of Strategic Partnerships and Technical Standards at Affiliates USA. We have Ashley Heineman with GoDaddy, who is their Director of Global Policy. We have Martin Levy, who is Distinguished Engineer with Cloudflare. And we have James Andrew Lewis, with Senior Vice President and Director of the Technology Policy Program with the Center for Strategic and International Studies. We also have, the video is going to be presented by Joseph Lorenzo Hall, who is an executive with the Internet Society, and he'll give us about 5 minutes of an explanation around network security and protocols, and then we'll have some more conversations with the panelists about what the implications are for those protocols. So with that, Dustin, if you could bring the video online, that'd be great.
Hello, I'm Joseph Lorenzo Hall. I'm an executive at the Internet Society, and my portfolio includes all the projects focusing on a strong internet. I apologize I can't be with you there today, but I'm hoping this video contribution will serve as a good conversation starter for the panel. I want to talk about network threats, or threats that apply to pieces of the internet below the application layer. That is, those things you usually don't notice, or the things that happen outside of the immediate interactions of the elements on a web page or an app or a device. I'm going to talk about network systems and protocols, and by a protocol, I really just mean an agreed upon method for computers to talk to each other. Unfortunately, we have a long storied history where the first versions of a given protocol were born insecure. But it doesn't have to be this way, and it is changing in a number of important areas that I'll point out. First thing I'll point to is HTTP, the web protocol. In 2013, about 20% of all page loads were secure using the HTTPS secure protocol, and now it's close to 80% according to Mozilla statistics. However, we've had a much more difficult time securing other pieces of the network stack, so to speak. I'll now get into 3 foundational technologies that I'd invite panelists to discuss: DNS, BGP, and NTP. DNS is the phone book for the internet. It has been insecure for a while. For a bunch of reasons, we just haven't gotten DNS security right over the years. There are some newer technologies, notably DNS over HTTPS and DNS over TLS, that have emerged that encrypt DNS queries, providing confidentiality and protecting integrity of the constant stream of domain lookups coming out of modern devices. But it's not enough to just encrypt the DNS queries, because it's just as important that entities on the other side receiving or responding to those inquiries treat the data carefully. We are big fans at the Internet Society of the Mozilla Trusted Recursive Resolver policy, and we're really glad to have companies like Cloudflare and Comcast signed on to commit to the protections and transparency of that program. We'd love to see many more offerings of encrypted DNS and adherence to sensible privacy criteria like the Mozilla TRR program. Second, BGP, the Border Gateway Protocol. BGP is a lesser known protocol that allows networks to announce how to get to certain IP addresses and IP address blocks, and it's unfortunately not secure. Routing incidents are important Routing incidents are unfortunately common when the internet roadmap is distorted and traffic goes not via intended paths, but via what we call route leaks or route hijacks. But there's an authenticated way to announce routes by using a technology called RPKI, which is very useful to prove that a given network is allowed to announce a given route. This is something we work with at the Internet Society in our Manners project. Manners, which stands for Mutually Agreed Norms for Routing Security, is a normative effort where network operators, internet exchanges, cloud providers, and CDNs agree to a set of actions that, if implemented, ensure that they are practicing good network hygiene. I'd ask the panelists, to what extent do they practice good network hygiene? For example, by validating routing announcements from their peers, or preventing the propagation of incorrect routing information, keeping their side of the street clean, so to speak. And if they do, I'd encourage them to join over 500 other participants that are Manners compliant. Finally, I want to talk about time. On the internet, time synchronization happens using a couple of protocols, normally NTP, the Network Time Protocol, and PTP, the Precision Clock Synchronization Protocol. If you've been following along, you may be able to predict what I'm going to say next. Yep, both of these technologies are insecure. However, the IETF just approved an extension to NTP called NTS, or Network Time Security, and the IEEE has just in June published the IEEE 1588 specification. This will allow for authenticated time synchronization on the internet. It's hard to communicate how much we depend on precise time. In modern times, we benefit from synchronization activities at very precise levels, often to the second or millisecond level, but sometimes even the microsecond or nanosecond level. High-frequency trading, cryptographic key expiration and protocol mechanisms, and the synchronization of robotic manufacturing across a factory floor all depend on making sure that the clocks across those facilities and systems are very precise and synchronized. As the security technologies for NTP and IEEE 1588 mature, we hope to see many more authenticated time servers providing quality time on the internet. And with that, my time has run out, authenticated or not. I hope I've been a bit provocative, and please take care, everyone.
All right, so I'd like to turn to the panelists now. And my first question, I want to ask them, a little bit about what they do in their organizations and where they fit into the digital ecosystem, and what role they have to play in terms of ensuring security, cybersecurity, network security, but as well as operations and applications. I think everything should be on the table for discussion today. So let me begin with Michael Benjamin. Michael, can you start the role?
Yeah, my pleasure. Thanks for having me today. So my role at CenturyLink is security. The remit that the team that I work in is focused on both providing the products and services to our customers around security, as well as all the operational security of the company itself. The third leg of our stool, so to speak, is threat intelligence, where we utilize a pretty massive data set for the global internet in order to understand where attackers are coming from, how their campaigns are operating, and then ultimately take action against breaking them in a goal of raising the cost of an operation to a criminal or a nation state, as the case may be. And so our focus is on security. It's a pretty big umbrella, and the understanding of how threats work in the internet and how we can impact making them more difficult for a criminal and foreign military intelligence, whatever the case may be, in order to operate and be successful. Our job is to protect our customers, protect ourselves, and hopefully clean up some of the internet itself.
Okay, very good. Thank you. Dr. Galvin, your turn.
Thanks, Robert. So I'm part of Affilius, and we are a registration service provider, registry service provider. So in the domain name system, we are the top level of the registry system. So Affilius is home to about 200 plus TLDs, including .info and .me, a couple of dozen CCTLDs, and the rest of them are all GTLDs around the world. So we run a very large DNS infrastructure, obviously, in support of all those TLDs, as well as supporting our registrars, who are the customer side of the domain name registration system. We are an active part of anti-abuse efforts in the domain name system. And so for me personally, I'm a security technologist. I work quite actively in standards and policy development these days on behalf of our registration systems. We have teams of people who are actively involved in those activities, and we proactively review all new registrations for domain names every day, looking for abusive behaviors, abusive activities, and seek to participate in taking those down or working with other players further downstream in the ecosystem to make sure that abusive domain names are taken care of. So this is kind of a background hidden activity from the rest of the user community. And that's how it fits into this overall architecture in the grand scheme of things. Thanks.
Great. Thank you very much. And Ashley, your turn.
Hi, thanks. Yes. Ashley Heineman, I work for GoDaddy, and we are a domain name registrar, so similar to Jim, except that we provide domain names more at the retail and directly to our end customers. We also provide web hosting service, and overall we have about 19 million customers, so quite a few. We as well are very focused on a strong, resilient, secure domain name system. We are very cognizant of our customers and making sure that their accounts are not compromised, because in those situations often we'll see bad activity, DNS abuse occur as a result of that. Also, through our web hosting activities, we're very focused on making sure that we are capable of detecting and dealing with a DDoS attacks, so our customers are not impacted by them, because we have the infrastructure to support them, and so therefore they don't need to see any kind of disruption in their activities. But again, like Jim, we're very active in DNS abuse activities, working with law enforcement. We rely heavily on notification of abusive practices. So that's pretty much where we stand. And much of what we do is what people don't see, or at least hopefully don't see. So we're there to try and prevent any bad actions taking place at that level. Thanks.
Thank you very much. Another infrastructure provider, Martin Levy, can you talk about your role and your organization?
Yes, of course, and greetings. Cloudflare, as some people know, we deliver services for about 27 million different domains out there, from very big to very small. We are an infrastructure company. We run in about 200 plus locations around the world. We provide DNS, we provide web, we provide access services, and more. But the part that I focus on, and it matches that whole part about hidden and don't notice by the end user, is that I focus on infrastructure. So as a company, those 200 plus locations are all running the BGP protocol. They're actually all running DNS as well, but they are part of the global infrastructure that makes up the routing that is the back end of the internet, the part that very few people ever see. And so I focus on that. RPKI is the security du jour that we're working on in the BGP world. We can talk about that hopefully much more. And in addition, we're very heavily involved in the IETF for things like the NTS protocol for securing NTP. We can talk about that a little bit later. So that's sort of the brief introduction.
I suspect.
Okay, I'm concerned that we might have lost Robert there. I'm not sure who he had on his list to go next, but why don't we pick one here? And Jim Lewis, you haven't introduced yourself yet. Why don't you pick up and go ahead while we see what happened to Robert?
Great, thank you. I hope he comes back. We're having some blackouts, as everyone knows, in the Washington area. I live in Washington. I work at a think tank that does policy analysis. My focus isn't technical. It's on cyber policy and politics. I've worked on norms at the UN. We have a giant 5G project now that looks at standards and the move to SDN and virtualization. I do a little bit on governance and how that might evolve and reform, and on cybersecurity policy here in the US. So this is a good topic for me, and I appreciate being able to listen to others and being part of this group.
Okay, back over to you, Robert. You seem to be on mute at the moment. We just went ahead and let Jim introduce himself, Jim Lewis.
Oh, okay. Am I back online? Hello? Okay.
Yeah.
Sorry about that, folks. And the electricity just went back on, so making my life even more interesting. Let me begin. Thanks all the panelists. Let me begin with a question, kind of the big 50,000-foot view of what kind of environment we're operating in. And maybe you can get large and perhaps challenges what can be done, should be done. And let's begin. Ashley, can we start with you?
Sure, happy to. You're breaking up quite a bit, at least for me. So I'm going to.
All right. Well, we're going to apologies for that.
If I understood you correctly, you wanted like an overarching high-level view of the problems that we're seeing and how we're dealing with.
Mm-hmm.
Again, I happy to. I mentioned this earlier. One of our biggest concerns that we deal with on a regular basis is dealing with the compromise of our customers' accounts. There's things we can do like promote good password hygiene and to utilize two-factor authentication. But a lot of what we see are vulnerabilities that are essentially just outside of our control. So having to deal with that and recognizing that oftentimes if an account is compromised, abuse is often a result of compromise. And what we're working on right now, well, not working, but what we rely upon and always have to a great extent is notifications of problems. There is no real silver bullet in terms of being able to monitor all of our customers' interactions and what they're dealing with in terms of DNS abuse. So notifications is really like the best way to deal with this sort of thing. There's just not enough eyeballs or time to do it 100% proactively. So with the notifications, we've learned a lot, specifically during this COVID situation, in terms of how to deal with notifications coming in at a larger scale, what is useful, what is not useful. We've learned that false positives in terms of people notifying against against behavior is very high, and what we need to do to inform notifiers, whether they're law enforcement or just somebody who's seeing some bad stuff happening on the internet, what kind of things they need to be doing in terms of due diligence and making sure what they're seeing is actually abuse, and giving us all the information we need to take action. Because at the end of the day, at a registrar level, we have really only a handful of very blunt instruments to deal with abusive practices. And oftentimes they aren't helpful. They don't solve the problem. So when it comes to taking down a domain name, we want to make sure that that is the best course of action. Otherwise, it's getting in touch with our registrants and bringing to their attention that there are some bad things happening, because they don't often know. And that's kind of the situation that we're dealing with. And I think I'll stop there and see where other folks are on the panel, because we do operate in a variety of ways, but that's probably the largest area we're working on right now. And hopefully too high level that you've lost any kind of useful information, but thanks.
Let's turn to Martin. Can you talk a little bit about your view of the threat environment?
Yeah, absolutely. And this is sort of a multi-pronged response because it all builds upon itself. Fundamentally, when you look at the lower level infrastructure of the internet, you look at the pipes, the tubes, so to speak, that that make everything work. They really are, because of the whole sort of 7-layer protocol model. They don't care about what the bits are that are being moved. They don't care about the application. They don't care whether you're talking to a bank or watching a cat video. They don't care. But what they really care about is where a particular IP address, the thing that routes a packet, depending upon where you're listening to me, where that flows and where it goes. So the routing table, something that started, literally in the hundreds way back in the early days of the ARPANET, hundreds of different addresses, became 50, 60, 70,000 routes as we ended up going into the sort of the .com boom. And we now sit regularly at the 800,000 plus routes. And each one of those routes is an address book on the infrastructure of the internet that says, if you want to get to this numeric IP address, go this way. If you want to get to that numeric IP address, go a different way. And when you're in that world, securing 800,000 odd routes from 60 plus, 70 plus active autonomous system numbers, different network operators, becomes not something that you can simply trust. You have to have process. And the internet routing table growth is on par with the growth of the internet. But some routes are very, very important. If you look at the panelists here that are running infrastructure, whether it be DNS or web or whatever, or backbone, those routes are absolutely vital because they provide the information, let's say DNS information, before you go off and actually pull a web page from a numeric IP address or location somewhere. The security, which was part of the introduction video earlier, the security was just not written into those early BGP, the Border Gateway Protocol specifications. If you go back into the mid-90s, 94-ish, and look at before that, and you look at BGP 3 and then BGP 4, the BGP 4 is the protocol that we run today, it simply did not address security. And yet today, when we look at either accidental or malicious attacks on the infrastructure, the routing infrastructure, then you see that you must secure the routing. And this is done via really two methods. The first method is an IP address that is owned by the likes of a large search engine or a video or a content delivery network or an end user inside a cable modem or a DSL or a fiber delivered connection. That IP address is allocated through the regional internet registry system with a complete and valid whois process such that you can look at who owns a particular IP address. But that isn't enough. That's not really machine readable, and it isn't usable at the high end with the size of the internet we have today. So through the IETF and through many years of work, we now are sitting at the practical side of route security in the form of RPKI. RPKI is a process that enables the allocation of an IP address to also have a cryptographically signed assertion of ownership and a mechanism through the routing registries that enables a particular route and a particular autonomous system number to be linked together so that the origin can be validated. In other words, it says that Cloudflare is allowed to announce a particular IP address, maybe the one that's on my t-shirt today. But also it says that I can accept through the infrastructure that we deploy, a different IP address from a different provider, a cloud provider, other content provider, maybe an access network. And I can confirm that through BGP, this is exactly the right route that should be accepted. RPKI, and for example, the ISOC manners program, isn't the end of the story. In fact, far from it. We've still got a lot more work to do. But this level of security enables us to actually do the first stages in securing this infrastructure over and above those very early days of running the internet, where essentially everybody knew each other. And therefore you could pick up the phone or instant message or email somebody and say, you're doing something wrong. Those days are gone. Those days are long gone. And so to keep the tubes and to keep the pipes operating, we really are sitting with this need for this cryptographically processed, with issues, but we've got time to talk about those, but a mechanism to make routing a lot more secure than it was. And we call upon, the industry in general has called upon more and more networks to take heed of this and to implement this and to deliver to their end users a more stable and secure and resilient backbone, to which all of the processes that we actually see on day-to-day on our screens, such as email, such as web, such as banking, such as whatever, those all then become built upon this secure infrastructure. So RPKI, BGP, this is work that has been gone on. I'll take a break, but we'll talk about some of the issues that still need to be operated, and also sort of the percentages of just how successful this work actually is. For now, I'll give back the microphone.
Martin, thank you very much. I'm going to turn to Michael Benjamin, and Michael, maybe you can start the conversation that gets to some of the challenges of deploying some of the solutions. I know Martin said we'll get to it later on, but maybe we can start, because I understand the cryptographic computing requirements are pretty substantial to implement that scale. But let me ask you, Michael, to start responding to that.
Yeah,
and
absolutely.
And the threat environment more broadly.
Yeah, so I do think the threat environment's a good place to start. The reality is that people who attack technology, they go the route that's easiest, right? So Ashley made a great comment. There's just a lot of vulnerabilities out there that no one silver bullet's going to solve. And the exploit that was announced last week, that somebody can go download off a web page, is a lot easier than attaining through many other methodologies. It's the vast majority of crime, the vast majority of infiltrations, data exfiltration, theft, is through hacking into an application. One of the most popular malware distribution methods in the world today is a malware family called Emotet. And the actors literally just hack WordPress sites for their malware distribution. That's it. Nothing more advanced, nothing more sophisticated. We see nation states, some of the most powerful nations on earth, they send an email with a link. We all know not to click links. It doesn't matter, it's effective. And so it is important when we think about the threat landscape that we look at this from a broad perspective, that threats are substantively in those lower hanging items that we all know, and we all tell our family don't click a link and use complex passwords, but that's where the weakness is. And so, however, we must have substantive layers of trust to be built on. Martin makes great points. And one of the points he made is that we're in a position where we need a ground truth to the data set that exists in the internet. For 30 years ago, we could email around a text file, or remote copy around a text file that had the routes and the owners. Can't do that anymore. We're now in a state where we need a better ground truth. The IRR mechanisms that have existed for a number of years, they got to 70, 80%, but that's inadequate. And so the cryptographic trust model that exists with RPKI is important to the future of how we get a ground truth, how we know who owns what, and we can build upon it. The somewhat unfortunate reality is that the implementation of RPKI filtering as the first step in that process is going to help us primarily with reliability, not with security. Now, reliability is massively important to the internet, but I selfishly get to be a security person and talk about the security side of it. The reality is that we need the later mechanisms that provide an end-to-end trust of how information is transited across the internet in order to actually be in a position where we know that the communication is trustworthy. So we have to know who owns it first, then we have to know where the announcements actually came from. In BGP, there's a mechanism, we'll call it the path that an announcement hops along. And that path is not trustworthy. So even if we know that it should come from a certain autonomous system, a certain network in the world, that message can be faked. So any actor of any sophistication could put themselves in a position to announce an untrustworthy route. So the net benefit today is largely reliability, fat fingering, redistribution of routes, mechanisms people make mistakes on. It's an important step along the journey, but it is a long journey. Martin said that earlier, and it's a great point. We have a long ways to go, and we need to continue down that journey. And I think things like Manners are a great position to bring together a community of people to work together and put us in that position. The RPKI mechanisms, you mentioned cryptographic scale. RPKI in and of itself as a signing mechanism to say who owns stuff is a relatively straightforward set of mechanisms. The validation of those routes in certain routers at certain scale is a very, very intensive thing. And so a number of network operators and a number of router vendors are continuing to work on the ability to implement those things in the core of the networks in an adequate place, because at the end of the day, we don't want to implement something that largely drives reliability in an unreliable way. That doesn't make sense. We need to implement it in a very reliable, very predictable way so that provides that net benefit and we can continue down the journey. Unfortunately, as of a few years ago, the standard around the end-to-end was something called BGP-SEC that put a huge cryptographic load on routers. And so there's a great acknowledgement among that community I described, the people working together, that we need to continue to consider how do we take the next steps along the journey and continue to make it something that we can, as an internet community, implement so that we can get to that point where the ground truth be fully enforced. Because at the end of the day, we all can trust our HTTPS, our CA chain, our mechanism to do that application level trust, but it would be nice to have multiple levels of trust inside that hierarchy of application usage.
Okay, thank you very much. I'm going to turn it to Dr. Galvin, your thoughts?
So thanks very much, Robert. You asked about a 50,000-foot level of what our threats are and what we think we're facing. I want to touch on something. Joseph Hall had mentioned DNS security in his opening video, and he only touched on one element of DNS security, and that was confidentiality. And he made references to DNS over HTTPS in particular, but the DOH debate for folks who are used to that acronym, DOH and DOT. And I think that he overlooked the fact that DNS actually has the opportunity to be a very secure protocol from the point of view of authentication and integrity, knowing that you're getting the right data. To the extent that DNS is the phone book of the internet, in other words, you really can't do anything on the internet if you don't know the name. And somehow, that name is really what's mapped to the numbers that Martin Levy was referring to, and routing deals with all of the number side of it. You have to get to those numbers, and DNS is how you get there. You want to secure DNS. And yet the DNS has been secure for 20 years, and yet its deployment has been minimal at best. And I think that just like routing, as Martin was suggesting, we've had routing since the internet was born, right, 50 years ago. I mean, you got to get stuff from here to there, so there's always been routing. But the secure routing is something which is getting a lot of attention lately. And in fact, it's really an accident waiting to happen. And in many ways, DNS security is in the same place. There's a lot of attention to confidentiality. That's what Go and Dot give you, is confidentiality of your queries. And that's interesting, and it has a lot of benefits and a lot of value. I made reference in the chat room to a document that actually goes through all of this in a lot of detail about what are the good parts of all of that, but it's not enough. The DNS is still an accident waiting to happen. You still have hijacking. And of course, this matters to us as an infrastructure provider, an essential infrastructure provider. We're providing a substantial DNS infrastructure to the world because we're hosting PLDs. And the ability to manage that and ensure that the right data is getting to the right place is critical. We worry about DDoS attacks, and we'd like to see more DNS security deployed, but we don't actually control that. That's really for the registrants and the rest of the user system to want to bring that about and make it happen. And I know that Martin, colleague over here, has a lot to say about that. Cloudflare is actually one of the more significant, providers of DNSX services to their DNS customers, and that's a good thing. I want to touch on something else, though, as a role that we have, and I think this applies to all of us here, and I want to call it out. We all have a responsibility to be good network citizens and to apply security services inside of our infrastructures and what we do as a significant component and a significant player in the overall internet ecosystem. And all of us have a role in that space. You have a responsibility to behave in appropriate ways and to deploy appropriate protocols. So routing is something that Martin had talked about, and he commented on, Cloudflare working on that kind of thing. And I know that others here do it too. We are too. You want to be a part of manners. You want to behave properly with respect to routing. You want to represent your own routes. You also want to be clean with respect to what you allow to leak or not leak to the internet. So I think that what I worry about at the 50,000 foot level is making sure that we continue to participate as a good network citizen. We want to be a part of the ecosystem and support others, and be responsive to threats that others experience. And I think that's an important part of the overall ecosystem that we need to care about. So I'll just leave it at that for right now. Thanks.
Okay, great. We have a lot of questions from the audience. I want to get a chance to present some of those. But before we do, let me ask Jim. I know you have to leave a little early, and I want to give you a chance maybe to speak to how generally you would view these discussions and your thoughts about the implications, both in the U.S. but globally as well.
Thanks, Robert. And I'm sorry I have to leave early, but you asked us originally to look at what is it we worry about, what is it that we're worried about? And I look at a different part of the ecosystem here. I look at the policy landscape, the threat landscape, particularly from state actors. So what I'm seeing is there's a new effort by different groups to say that the protocols we have now are not sufficient, right? And we need a new IP or something. And some people will say, the internet is too important to be left to the multi-stakeholder community. Now, how far these will go is another matter, but you see some of this in the ITU. You see some of this in the UN with some of the high-level discussions they've had there. And so what I'm thinking about is more, what do the proposals for new protocols, do they have legs? Maybe not. People talk about bifurcation of the internet. I don't think the goal here is to bifurcate the internet. I think the goal is to take it over. So we're in a different situation than we were, 25, 30 years ago, because now there's a contest for how we might re-engineer or recreate the new role, the new protocols. I think this is important because one of the things that all the speakers have said, maybe they won't agree with this, but I don't think you can rely on consumers. I don't think you can rely on your customers. And we go through this a lot. If only we would train them not to click on that link. Mm-hmm. Well, I'm an attacker. I'm going to hit 1,000 people, and I can count on at least 20 of them making a mistake. So we're always going to be vulnerable. And that leads us back to this discussion of the threat landscape, state actors, what we can do to make the internet more secure, and the fact that other people now have a different and maybe more controlling, they call it multilateral. Multilateral is code for government, right? A different view of how we need to restructure the internet as we move forward, what sort of new protocols are needed. So that's the threat I think about. It kind of fits into this discussion, but I'm eager to hear what the others have to say. Frozen again.
Okay, so we lost Robert. Let me suggest, Michael, I don't believe that you've spoken yet. Why don't you jump in and respond to the question too on the table?
I did speak, but I'll speak quickly. So In response to the concept of, do we need an entirely new way to think about the problem because it's so bad? I don't think so. I will tell you, some of the panelists here, I know firsthand, our companies directly collaborate on cleaning up threats in the internet. We work together to make things better. We continue to work on the standards and the protocols and the improvements as a collaborative environment in a very similar way to how the internet was founded. So at CenturyLink, we may be this giant network operator. We're still concerned about a piece of malware, a website. And I know from the collaboration that we do with others that they do too. We all care, and we continue to be successful in that cleanup. So do we need an entirely new way to think about it? No, we need to continue to build on what we have today, continue to collaborate, continue to innovate, and continue to hold each other accountable when we see gaps in that, and make sure that we continue to improve as a community the same way the internet was founded.
Yeah, I actually, if I may, would respond to one of James's comments, is you can't rely on the consumer. And yes, I agree, but as an infrastructure person, I'm very much far away from the consumer. So I look at it from a different point of view. I look at it as I have to do everything possible such that the consumer can rely on the internet. And there are gaps, there are major gaps in that statement. But at least from the infrastructure upwards, you have to do everything possible. You have to make sure that you're securing stuff and giving at least the best opportunity to the application writers and to the operating system writers and the mobile device software writers, such that things have the opportunity to go right if all the right things. Changing humankind is a whole different panel, which I don't think would even take, 2 days wouldn't be enough. So there's actually one example. The three introductory protocols of this session was DNS, which we've talked a little bit about, BGP, which we've talked a little bit about, and that third one is time. And it's actually really interesting just to explain just what the inner workings of the infrastructure of the internet is doing in the time space, specifically in the secure time space, where that actually has a real effect on the end user to stop attacks happening, whether it be replay styles or whatever, in the sense that secure time, even just improved time protocol, but improved time infrastructure, but definitely secure time protocol with things like NTS, have the ability to make sure that everybody's browser, everybody's access to a certificate in an application or in a browser or in wherever, actually has more chance of being accurate and not be spoofed by something else. Because certificates have learned to keep the time much tighter, the TLS protocol, such that if we can keep people's devices with much sharper time, then we have reduced the potential for an attack surface that is crypto with expired certificates or replay, etc. So we're doing about as much as we can on the way up, but can't talk about the humankind side of things. That's a different conversation.
Does any of the panelists want to respond on this discussion? Because we'll go to a question then.
I could jump in real fast if you don't mind.
Okay. Sure. No, not at all.
Okay, yeah, this is Ashley again from GoDaddy. And I'll be brief, and just to touch upon some things that I believe James raised and also have been noted by both Jim and Martin. We have a lot to work with already in terms of protocols. And I think we can improve on implementation and deployment. And I think also looking at incentives, because if you use DNSSEC as an example, I think there's a lot of operators out there and platforms that want to support DNSSEC, but there's a lot of complexity. And I think that applies to ARPKI as well. And you can do the right thing, you can enable it, you can offer it to your customers. And in my case, website, putting up websites, they are the end user and they don't see the value. So I think there is still room to improve upon protocols that we already have. And to go to, governments taking over and that being the big question, I feel like I've been dealing with this my entire professional career. But to talk more positively, I think we have a lot of opportunities right now to look at voluntary initiatives when it comes to dealing with security issues, cyber threats, DNS abuse, whatever it is. And I think there's a much more willingness now to go down that path where there may not have been in the past. And I think we have a lot of good examples to pull from and build off of. So hopefully that is the wave of the future, as opposed to the need for a heavy-handed government step into the process, whereas government is a partner and a player, but we're all part of the ultimate game. Thanks.
Okay, thank you very much for that perspective, and I think it's an important point. I want to combine a question with it's coming from the audience as well as something we said we would talk about. The question talks about, given the ever-increasing and persistent attempts by bad actors, what do you see as the top cybersecurity issues, threats that we should look for in this next year? And I'm going to add the question we talked about, what scares you the most that you or we collectively as an ecosystem don't necessarily control? Who would like to start with that question? No volunteers, I'll
Okay.
just pick people.
So
Mike,
go
you wanna maybe take a shot at that, top threats, and what do we not control? Okay, go ahead. Go ahead.
Jim, it looked like you were going to speak. I'll let you go ahead.
Okay, thanks, Michael. Yeah, so I think what's interesting to me about bad actors and what keeps me awake at night, if you will, is never really knowing for sure where they're going to attack and how they're going to attack next. Okay. One of the problems that I face in dealing even with domain name abuse is the fact that there's this desire and there seems to be this inference that the amount of abuse and the amount of bad actors should always be down to zero. And the problem is you really can't prevent abuse because the bad guys are out there. You don't really control them. They're going to do stuff. And I think as we've sort of touched on here in a number of areas, even the 3 areas that Joseph Hall gave us in the beginning, and we've touched on a couple of others here, there's quite a landscape. There's quite a threat landscape available to the bad actors. And I think that when you think about what is it that users don't understand, I think there's the assumption that users have that everything is just fine. I think that users don't appreciate that things are not fine because things really do seem to work 95% of the time. There are those of us here and, you know, at the table and most of us, actually many of us in the industry, who do a lot to help the user, to protect the user. We do a lot to make our services the best that they can be from a secure and stable point of view. And yet it's not enough because there's always a path in for the bad guys. So, you know, what is the kind of thing that keeps me up at night? You know, the service, one of the services that we provide is our DNS infrastructure to the rest of the world on behalf of people who have domain names and the registries that we host. That's an essential service to the internet, right? I mean, the internet doesn't work when the DNS doesn't work, at least to the largest part of the user community. And with that in mind, I worry about what is the next botnet attack that's going to come around, because that's the kind of thing that most directly affects my DNS infrastructure. That's the kind of threat that gets to my infrastructure, the ability for people to either make me an unwitting accomplice in some kind of DDoS attack, or they attack, you know, my infrastructure itself directly, and thus make it difficult for me to provide my service to the internet at large. And you know, that's something that we care a great deal about and we monitor. It's the customer impact that we're trying to fight, and it's the things that the users don't see. They don't realize how much goes into and what it takes to protect against that, because it's not a visible activity to them. And frankly, the average user doesn't even know what a domain name is anymore, right? People go to their browser and they type in whatever and they get whatever. So the domain name system is supporting the rest of the infrastructure more than anything. So anyway, that's just my thoughts in that space. Thanks.
Thank you very much, Martin. Michael, you were saying, so why don't you respond?
Yeah, I actually saw one of the questions in the audience that ties into this is how do we raise awareness and educate users? And it ties into what you just said. You're right. A lot of users don't fully understand, and it goes to the panel of, there's underlying infrastructure components that they are never going to understand that are on us as infrastructure providers, as people that provide the core of the internet from a functionality perspective. We're going to need to continue to provide those things. But how do we see them improve on their own ability to help us? Education. We're never going to solve the problem. It's been said a few different times. They'll never go to zero. But our goal in life should always be to raise the cost of that attack, make it more difficult at all times. If we can do that every day, we are making improvement, and we are going to lessen. We're going to make it easier for somebody to go get a software development job than to write malware. They're not going to attack the BGP system if they can get more money by defending the BGP system. This is where we want to be as an industry. And so educating users, one of the things that we have found CenturyLink to be very effective is through our malware tracking, our botnet campaign tracking and everything else, is just telling users when they interacted with it, telling users when they became a part of it, telling them a little bit about the malware family. Be amazed how many times that person who may never know those words says, wait, what happened? Wait, how do I stop that? Right? Don't connect that DVR that you bought for $50 off Amazon directly to the internet. You've created an unreasonable attack surface. This is how port forwarding works in your home router. Wow, I didn't even know that response that you get. And that's how the bad actors built a 1 million node Mirai IoT botnet, was just on cheap DVRs exposed to the internet, right? And so as we think about how do we lessen that, it's information to that community. And the rest of it's just depressing. It's patching, don't click on links, change your passwords. The same things we've been saying for years. Those are the things that drive a lot of the overall risk to the internet, is those simple little things. The next worm that comes out that hits a public attack surface service that is an easily exploited item, that's frightening. Those are the things that can impact the internet. Those are the things that can create million nodes pieces of infrastructure that can seriously impact how things operate.
Very good. Dr. Galvin.
Yes, I did speak before. I think you had referred to me as Martin, but I would like to add something if you don't mind.
Sorry about that. Okay.
Yeah, no, that's okay. I want to go back and touch on routing security a little bit more too, since we're there. This panel really is about things that users don't see or should see or don't understand. Bringing this background to something that Joseph Hall had talked about earlier before in routing security, I think that is one of the biggest threats and accidents waiting to happen in our community. This will set up Martin ideally, I think, to speak more about this in his infrastructure and his sites around the world, the number of sites that he has. The problem with routing security is that users aren't even aware that it's a problem. They don't see it happening. I mean, things make the news. Like even in the last 3 years, we've seen just huge reports about all internet traffic being rerouted accidentally, presumably. That remains to be seen. But Google, Facebook traffic going through Russia. Okay, route leaks that cause all the traffic to go through Russia, all your traffic to go through China. Okay, those kinds of things have all happened in the last 3 years to each of those companies. For an hour or more, all the traffic goes there. And the question is, most users would never see that, would never think about it, don't understand it. And even when it makes the popular press and it makes big news, they don't even know what it means to them. And that's part of the problem. I think that's one of the things which is holding back routing security. I mean, the internet works because most people cooperate to make it work, but we really should do more, because imagine the loss of information, the data leakage that comes from all traffic being routing through other nation states or other places, because routing itself is not secure. It's just sort of something that everybody agrees on. And how do we make the world better for people? I think that, we all have an obligation for that. And IXPs in particular, your internet exchange points, as well as significant providers like ourselves and other kinds of providers who have large infrastructures, large numbers of data sites. And I'll close on this one final note. Think about cloud service providers in general and the number of sites that they have around the world. What happens if their routing, and this is kind of what happened to Google even, right, a year ago, was having all of your traffic routed somewhere it doesn't belong. So now everything that's going on that site is moving somewhere else. What can those nation states do with that data? That's the risk. That's the threat that we all face that I don't think people realize. Thanks.
Yeah, very good. And I'm sorry for the name change there. Martin, can you respond?
Yeah, the real Martin. But I'll lend my name to anybody, especially on this panel. It's a great setup. It's a wonderful setup. These hiccups that we've had, and they've been documented over the years, that again users don't see. If we go back to sort of this core issue of what are we talking about, things that don't see, there's actually a question. There's a question in there which was has the conversation digressed from the topic of attacks users don't see to security implementations. So the answer is yes, but in order to talk about those attacks that we don't see, we have to talk about the way that we implement security, and it's very hard to separate these two things. So let's take an attack that users didn't see but were affected by, or a subset of people were affected by. There was an attack about 1.5 years ago in the routing tables, and this will set me up for where I want to go to respond to all of this, where a cryptocurrency exchange, its IP addresses were hijacked via some DNS servers, and no one on this panel, I may add, over a period of time during that route leak and route hijack, which was very geographically limited, the crypto exchange managed to, or the fake crypto exchange managed to garner a couple of $100,000 worth of cryptocurrency, predominantly by putting up a fake website and then having the users literally say, your password is invalid, please click here to reset it. And they did. So it turns out that the routing was at fault, no doubt about that, and well documented. Yet the consumer, the end user, still did the wrong thing. There were so many indicators that they were going in the wrong direction, and yet they still clicked, they reset their password, they typed in their account information, and woof, money or cryptocurrency converted to money disappeared. Since then, the particular provider that was providing the DNS for this has in fact gone down the road of implementing RPKI, and intends to do much more. And this sort of sets me up for the type of answer that I want to throw back to the conversation so far. Although I mentioned earlier that the internet is made of 800,000 plus routes and maybe, as I said, 60, 70,000 autonomous system numbers, individual networks operated by different people, the reality is this isn't Animal Farm. Some autonomous systems, some networks, some IPs are far more important than others. The autonomous system number run by a Google or a Facebook, or a Twitter, or a cloud provider like an AWS or Azure or GCP or Oracle, or even a Tencent or a Baidu or whomever else, depending on adjust your geography for this conversation however you want, an M-Pesa processor in East Africa. Those routes within the geography that they cover are very important. So it turns out that one of the things that was realized is you really want to impress upon a finite number of networks very quickly that they need to improve their security and therefore reduce the ability for these attacks that can't be seen by the end user to be addressed. And when you get that smaller subset of networks enabled with better security, whether it be DNS and DNSSEC, whether it be BGP and RPKI, whether it be time and NTS, then you actually move the needle significantly. Unfortunately, that doesn't mean you can rest on your laurels. In fact, far from it. You, in fact, actually then immediately have to go after the next percentage and the next percentage, because there is no end until everybody is done. So you have to look at content. You have to look at content that absolutely must be secure. You have to look at infrastructure like DNS. You have to look at access networks. In fact, in the end, you have to look at everything, such that the underlying infrastructure is considered to be as secure as it can be. There is no resting on your laurels. There, for example, and this was mentioned earlier by Jim, that if we get RPKI and route origin validation to 100%, we are in no way finished with route security. And I know that all of us on the panel sort of understand that, but it is important that we have to state it and state it again. And Michael mentioned this as well, but in a slightly different way, that this was or this is part of what the internet is about: security, improvement, the IETF process, the network operator group process, whether it be the RIRs, different ISTAR organizations, all of which are involved in just this continuous improvement of the internet. Because as was stated, yeah, we are going to get new attacks and new vectors, and we in theory have to keep ahead of that. So so if you're running a big network, do as much as you can to secure it, but then don't rest, because you still have plenty more work to do.
Right, and I think you very effectively speak to the shared responsibility that exists in the ecosystem. No single player or
absolutely no single player.
Right.
You can secure yourself, and you can therefore also accept security from others, but you're not done. You literally have to go out and convince the next and the next and ad infinitum.
Yeah, and to Ashley's point about policy and law, the level of innovation that's required to address these things, the pace in which technology advances, really lends itself to collaboration and innovation. So I'll make that point, and then I'll turn to Ashley to round out on this question.
Thanks, Ashley, again with GoDaddy. And I'll take this back to a less technical perspective and more of a policy perspective. It would be great if this was a sexy issue and we weren't the outliers and thinking this is all really interesting, because the fact of the matter is it's not for most people. So without that luxury, it's always going to be an uphill battle to get the end user aware of these things and doing the right thing. But I wanted to kind of just touch upon something that's bubbling up in the chat, not necessarily directly, but this, I think, general problem that stands the test of time, unfortunately, is legislators, lawmakers. It would be great if they could be working hand in hand with law enforcement, with cybersecurity experts, so we don't constantly find ourselves in situations where laws are put down that make it hard for us to be up to speed as much as we should be, or finding ourselves on the back foot because we are all of a sudden exposed as companies to extreme liability. It's just unfortunate that it tends to happen that way. Oftentimes companies find themselves damned if we do, damned if we don't. And I think a lot of the emphasis is misplaced. If there was a way that we could get legislation to be, it's never going to be completely right the first time, but closer to right would be helpful. If there was a way to better educate and influence legislators early on in the process to help companies do what they need to do and to meet the needs of the rest of the world, whether it's companies, individuals, or law enforcement, I think that would be a great step in the right direction and could save us a lot of time and energy moving forward. So I'll stop there. Sorry if that was obtuse, and I'm happy to take any more questions. Thanks.
Thank you, Ashley. So I want to bring out one question from an audience member here. It touches on policy, but it's the broader framework of how we work and collaborate. The question is, with regard to partnerships, can anyone provide examples of such, to include public-private partnerships and the impact and outcomes of those partnerships and venues? And I'll turn to Mike Benjamin for that to begin with. Thank you.
Yeah, thanks. So at CenturyLink, we have a pretty unique visibility to where threats are happening in the internet. And as such, we have to collaborate on that. There are plenty of security companies with great malware visibility that can't trace back the entirety of the command and control infrastructure, or the entirety of the impact on a threat. There are folks in all of our ecosystems that have pieces of that pie. And so collaboration is key in order to find that. But at the end of the day, actors hit a certain level of sophistication where us no routing, taking away their domains, shutting down their VPS hosts as a community is an annoyance to their operation. It doesn't truly impact the criminal's ability to execute. And at that point, it necessitates law enforcement relationships. And so we've been very, very vocal about the need for everybody to be working with the world on this problem. And so whether that be providing victim lists to the national certs of particular regions that are impacted, or interacting with law enforcement and helping them build an ability to arrest somebody, to be able to take their proceeds away, whatever that mechanism has been, it's been very fruitful where successful. It's a balance that we have to keep in mind of protecting our customers, protecting the internet, and the ability of law enforcement to have a finite queue that they can go through. But when they are able to hit those larger actors and make an impact on them, it's a great thing to see. It's very motivational to our team when they actually get to see a picture of the people they've been hunting in handcuffs. Let me tell you, gets people to go back, and there's a couple more years of motivation to go to continue to do that work. And so from a security perspective, the public-private partnerships around hunting down, arresting, and even going and helping victims have been very fruitful in regards to how we raise the cost of performing crime on the internet.
Very good. Dr. Galvin, where do you see the partnerships and the collaborative efforts working, and perhaps some examples of progress that's being made in some of those venues?
Well, for us, what we do in terms of domain abuse is it's important to have partners with your registrars, okay, because they're the ones that are closer to the registrant. And there are some registrars who are much more proactive, such as my co-panelist here, Ashley, and I'm sure that she can speak to the efforts that GoDaddy does. But we support thousands of registrars. Those are our channel for dealing with abuse, and so it's important to have a strong contractual relationship and strong terms of service that are listed there that allows us to work together and cooperatively to deal with domain names that are abusive. In addition to that, we work on the other side with law enforcement. Now, from our point of view, we work closely with a number of law enforcement agencies to facilitate their investigative efforts. So we have our security team has relationships with law enforcement around the world. And in fact, as a generic service provider for general TLDs, including CCTLDs, we have special relationships on behalf of some of our TLD customers. So specific example, there are CCTLDs which actually want to work quite carefully and quite closely with their local national jurisdiction law enforcement. And so we have those relationships on behalf of them. They set those up for us as part of us hosting their TLD. And so we have special procedures and special processes for working with their law enforcement on behalf of their TLD in maintaining those kinds of things. Excuse me. The last place in which we have strong partnerships is, in general, there's this problem and this concern about threat intelligence. Okay, you need to be able to share with a variety of people who are in the ecosystem what is happening in the world. So law enforcement is one piece of the puzzle because those are, obviously legal, if you will, complaints and abusive. So they're a trusted notifier. You've got registrars out the other side for dealing with the takedowns. But in addition, we want to proactively review all registrations just because we provide abusive services. So our notion of being proactive is maintaining relationships with certs around the world, being a member of appropriate organizations like MOG, those kinds of things, and being actively taking in those There's also the Cyber Threat Coalition Initiative, the COVID Coalition Initiative that was recently started by ICANN. You know, we actively participate there. We also have, we depend on reputation providers. So Spamhaus is probably the most notable example, but there's a few of those around in the world, and we like to have those relationships to make sure that we get feeds of various quality of, you know, reputations of domain names in order for us to evaluate registrations and make decisions about them. So the partnerships are an important part of the ecosystem. There's a role for many different people, and we try to maintain all of those relationships in an attempt to keep ahead of domain name abuse. Thanks.
Thank you very much. Ashley?
Thanks. Ashley from GoDaddy. Jim just did a great overall kind of picture of how things are handled in the DNS space. Specific to registrars and what we've been doing, and I will, for the sake of time, just focus on one area, which is what we've just experienced recently with COVID, is that our relationships are constantly evolving. I would like to say that they're improving all the time. We're learning about each other. I mean, just working with law enforcement and government agencies, just understanding what information we need to be helpful, who we need to talk to. We're building direct relationships, direct, you know, platforms to be used to get us information, but also going back the other way. When we see bad activity, it's often hard for us to get to the right people, particularly in law enforcement, and knowing that they're being acted upon and not just going into a black hole. And that's not to criticize, it's just like, how do we get that channel of communication open for both sides? Because I think, you know, there's often a bad perception of how things are handled. But I think at the end of the day, and what we've experienced, particularly under COVID-19, is that people do want to do the right thing. They want to be helpful, but we need to have the certainty that allows us to do those things. Very easy example, all the information that we need to take action. And just one very small example is that we were getting lists of thousands and thousands of domains, and with nothing but, these look like they have some bad, some misleading information. That is not going to be very actionable for us, only because we actually have people that have to go through each and every single domain to see what is bad there. So as much information that can be provided to us, like this, we have seen, you know, phishing, like botnet related activity associated with this. We have gone, like, just to show that some due diligence has happened. So that takes some of the work out, so we can immediately do what we need to do rather than having to do the due diligence all alone. So I'll stop there, but I think there's a good story here, and I think that is showing more and more, and I think we have a lot to build upon. Thanks.
Very good, thank you. So we're getting near the end, so Martin, you get to be clean up on this question. Partnerships, collaboration, outcomes?
Yeah, it's nearly all been said. I'll throw out a different one because it's a bit of my pet project. I mentioned earlier that we're looking at route security because of, you know, cryptographically signed data from an authoritative source. The internet has evolved dramatically over, well, I mean, I started writing TCP/IP code in 1982, so it's been a while. Interestingly enough, the protocol, the whois concept, the database, the protocol has lasted that long. And as much as we've been trying to, kicking and screaming, replace it with RDAP, we're not quite there yet, and we're close. But without opening that bag of worms, there is a very key point that comes out of some of the work that's been done in the RPKI world. When you cryptographically sign something and you have a chain of authority, and you know who the root of that authority is, which in this case is the routing registries, you have the ability to look at something, at least in this case in the routing world, and have a definitive assertion as to whether it's correct or not correct. And ownership of IPs, although there's still, it's not perfect, it has a lot more information in it that law enforcement, LEAs, can use and do use in order to track down where something comes from. It hasn't gone to the point of proxied anonymization that domains have gone, but it still has it has some stuff in there. So the point is that, just to hit the point about infrastructure that we don't see, those internet addresses that the end user doesn't see, that cause the routing, at least the LEAs have some access through the routing registries and through looking at the ability, at least these days, of RPKI, and actually see that there is authority for a particular IP address, and the ownership can, at least in most cases, be found. Not perfect, not a perfect answer, but there is work in that area, and there are a lot of LEAs that have become quite savvy about IP addresses, as much as they had become savvy about domains and ownership. So, you know, there's work in that area.
Very good. And I'm afraid you've had the last word, Martin, and I apologize.
Bad idea.
Apologize. Right. I apologize to the audience members who we couldn't answer all the questions. Clearly, we could go on for hours on any one of these questions. So I want to thank our panelists and thank the audience, and hopefully we've said something here that will stimulate some good thinking. Good afternoon, and thank you, panelists.